Hey guys, this next lesson we're going to explore what are called piecewise functions. You're going to see from the graphs of these that these are basically just functions that come in different pieces, hence their name. Up here in the box you can read through these steps on your own. We're just going to start an example and work through that to give you a better idea of it. They're going to be a little bit similar to graphing inequalities and number lines you're going to see in terms that we're going to use solid dots anytime we see a less than or equal to sign or a greater than or equal to sign for the domain, and we'll use a hollow dot anytime we have a non-equal to inequality sign. Okay, but again, you can read through all this up here in this box on your own. We're just going to start our first example and let you see this live. Okay, so we've seen piecewise functions before when we were evaluating functions back in the first lesson, and that's where you just had to look at the domain, which is right here, okay, and this tells you which piece to use. So like if you had f of, let's say, -2, you knew you plugged it into the top piece because -2 is less than or equal to 1. If you had f of 3, then you plugged that into the bottom piece because 3 is bigger than 1, and so you follow the signs here. So now what we're going to do is we're going to look at what the graphs of these kinds of functions look like. So I'm going to do that by starting with a t-chart. And this t-chart I'm going to make is only going to apply to the top piece of my function. So this piece right here is what we're going to make this t-chart for. Okay, so we're going to do our x values. I'm going to leave a little bit of space there in the middle just for some work, and then also going to do my y values. And the first x value I'm going to plug into my t-chart is actually going to be what I call the boundary point. The boundary point I get from my domain right here. Okay, so because my domain says that x has to be less than or equal to 1, I'm going to use that number in the domain, +1, as the first entry in my t-chart. Okay, and I call that again my boundary point or my BP. Okay, then I'm going to follow the domain. Because the domain says x has to be smaller than 1, I'm going to choose 2 more x values that are smaller than 1. So I'm going to choose 0 and -1. And now I'm just going to plug in each of these x values to my top function, which is f of x equals 2 times x minus 3. Okay, and so to get the y values for those, for +1, it'd be 2 times 1, which is 2, minus 3, which is -1. This would be 2 times 0, which is 0, minus 3, so 0, -3, and then 2 times -1 minus 3 would be -5. So now I'm going to graph each of these over here, starting with 1, -1, and keep in mind 1 was my boundary point, so I want to pay attention to what kind of inequality sign did they use here for this top piece. It's a less than or equal to sign, so when I make this dot, I need to make it a solid dot, okay, because it's a less than or equal to. Okay, and you only have to worry about that for the boundary points, for that very first entry that you did in your table. Everything else, 0, -3, -1, -5, I'm going to make as a normal solid dot, but that's just because they're regular points. Okay, and now I'm going to connect those dots. This top piece right here is linear, okay, 2x minus 3, so it's going to be a line. But it's going to be a line that only goes to this blue point right here. Again, that's my boundary point. So it's going to stop right there at that point. It's actually going to be more like a ray than anything else. So it's going to look something like this. Okay, and that's going to be the top piece of my function. Now I'm going to go ahead and do a t-chart for my bottom piece. In basically the same way. Okay, so again, I'm going to start with my boundary point. My boundary point is, again, +1. That's where I'm going to start. But this time I'm going to pick values that are larger than 1 because it says x has to be greater than 1. So I'm going to pick +2 and +3 to plug into my function. This time my function is 3x plus 1. So that'll be the rule I use for these x values. And 3 times 1 plus 1 is 4, 3 times 2 plus 1 is 7, and 3 times 3 plus 1 is 10. So now I have these points to graph. My first point, my boundary point 1, 4, again I need to look at the inequality sign. This is a greater than sign. Okay, it doesn't have the equal to bar, so I have to use a hollow dot when I graph 1, 4. So it's going to look like this. Okay, that point right there. 2, 7, and 3, 10. Okay, those are not boundary points, so I'm going to graph those just like normal. They're going to be regular old solid dots. And then I'm going to connect those points as well. Again, this time I start at my boundary point, and I'm going to be going this way, okay, for another line. So that's how you graph a piecewise function, okay? You just make a t-chart, okay, for each individual piece, but you have to pay close attention to the boundary points, okay, and make sure you're making those dots solid or hollow depending on what your inequality signs say. Okay, let's try another one. Let's try number 2. This one we have f of x equals negative 2x plus 8 for all of x less than or equal to 4, and then 1/2 x for x is greater than 4. Okay, so my top piece, I'm going to go ahead and do that in blue. My boundary point is 4, so that's where I'm going to start. X is less than or equal to 4, so now I need to choose values smaller than 4. I'm going to choose 3 and 2. Stay as close to your boundary point as possible. That's the good rule of thumb to do here. And I'm plugging into negative 2 times x plus 8 for this one. Okay, so we have negative 2 times 4 plus 8. That's going to give us 0. Negative 2 times 3 would be negative 6 plus 8 would be positive 2. And then negative 2 times 2 is negative 4, plus 8 would be positive 4. So my boundary point 4, 0. I'm going to use a solid dot for that one. So plot that right there. And then 3, 2, and 2, 4. Okay, and there's my line for those. And now I'm going to try a t-chart for the bottom piece. Why don't you go ahead and pause the video and try this part on your own, and then once you have your t-chart done, go ahead and click play to check. Okay, here's what my bottom t-chart looks like. My boundary point again is 4, so I'm plugging in 4 to my bottom piece. Half of 4 is 2. Then I chose even values for my next two x's just because I knew I was going to be taking half of them. That saved me from having to deal with decimals. So when I plug in 6, half of 6 is 3. When I plug in 8, half of 8 is 4. So I'm going to plot 4, 2. It's a boundary point, and this says x is greater than 4. So again, I have to use a hollow dot when I graph 4, 2. Okay, so 4, 2 is going to be right there, hollow dot. And then my other two, 6, 3 would be there, and then 8, 4 would be there. Okay, and then I'll connect those, and that's what this function looks like. Okay, so that's how you graph a piecewise function. We're going to take a look now at another type of piecewise function. This is a special type of function. This is called a step function, and it's just one where each equation is a horizontal line. And it's called a step function because once you get done, your graph's actually going to look like the steps of the staircase. Okay, so this is what a step piecewise function looks like. It's basically a bunch, again, a little horizontal lines. This says f of x equals positive 1 for x values between negative 8 and negative 4. X equals positive 3 for values between negative 4 and negative 1. And f of x equals 7 for values between 1 and 6. Okay, so what I'm going to do for this is start with the top piece. I don't need to make a t-chart really for this because each of these values is a constant. Okay, 1, 3, and 7. I'm just going to look at my domains here, and my first piece I know starts at negative 8, ends at negative 4. Okay, both of the signs are less than signs, so I'm going to use a hollow dot for both of those, and the y value is positive 1. Okay, so what I'm going to do is I'm going to go to positive 1. Imagine this as one big horizontal line. Okay, I'm going to make a hollow dot at negative 8. So imagine positive 1 just has its own kind of number line. Make a hollow dot at -8, and also make a hollow dot at -4. And then we're just going to connect in the middle. We're going to connect all those x values between -8 and -4. Okay? And that's my top piece. My middle piece, f of x equals +3 for x values between -4 and -1. So I'm going to go up to a y value of 3, okay, this imaginary horizontal line right here. I'm going to start at -4. This time it's a less than or equal to sign, so I'm going to put a solid dot there, okay, at -4, okay, on, again, the y value of 3. Okay, so solid dot right here, hollow dot on -1, and connect those two lines. Okay, and then lastly, my final piece, f of x equals 7 for x values between 1 and 6. So I'm going to go up to 7 and put a solid dot on +1. Okay, so right there, solid dot, and then a hollow dot on 6. And connect those points. So again, you can see it looks kind of like the steps of a staircase. This is what a step function looks like. Okay, final two examples. We're just going to do the reverse for these, and we're going to practice writing a piecewise function given the graphs. Okay, so for number 4 right here, this is our graph, okay, and we're going to write a function to represent this graph. Okay, well, to do this, you're going to determine, first of all, how many pieces there are in your function. Okay, in this case, we have 2 pieces, and so that means our piecewise function is going to have 2 parts to it, and now we just need to write equations for each of those pieces. So I'm going to look, first of all, at this left piece here, okay, and I'm going to try to write an equation for this line right here, okay. So I'm going to just go ahead and do this one in blue right here. This is going to be my blue line. And this is just like writing an equation for a normal line given a graph. Okay, we've done this before. So to write an equation for a line, okay, you need 2 things. You need to know the slope of the line and then the y-intercept of the line. We want to do our equations as simple as possible. So we're going to go for y-intercept or slope-intercept form for these. So the y-intercept, okay, we can see is 0, 1. Okay, so my b value is 1. My slope, okay, is if I pick this point here and this point here, down 1, 2, 3, 4, and then right 2. So that would be a slope of -4 over +2, or just -2. Okay, so the slope is -2. So for my blue line, okay, its equation would be y equals -2x plus 1. Its domain, okay, let's look at the domain. Well, its boundary point starts at 2. Okay, boundary point starts at 2 and it goes to the left. So it is accurate for all x values less than or equal to +2. Okay, so that would be the equation for my blue line. Now let's look at the red line, which I'm going to call this one here my red. Okay. For this line, this solid point, or this hollow point right here, it tells me what the domain of this is going to be. Okay, I see it starts at 2, and it's a hollow dot, okay, and it's going to the right. So I know the domain of this is going to be x is greater than, okay, no equal to underneath, greater than +2. It doesn't really tell me what this point is, okay? I can't really say that's 2, 2.5, okay? So I'm going to go to this point right here, okay, that it looks like it's going through. That's a little bit more accurate, okay? And we know that's 3, 3 right there. And then I also know out here I have 6, 5, okay? Neither of those is the y-intercept, okay? So what I'm going to do for this one right here is I am actually going to count and figure out what my slope is first, okay? My slope is going from here up 2 and right 1, 2, that'd be 3, okay? Positive 2/3, okay? So I know my slope for this one is m equals 2/3. Well, if it's positive 2/3, that means from this point right here, I can go down 2 and left 3, and that would put me at 0, 1. So if I were to imagine extending this line down, okay, its y-intercept would be 0, 1, okay, just like the blue one. So b value equals 1, and so the equation for this line is y equals 2/3 x plus 1. Okay, so to write this now in piecewise format, I'm just going to take both of these equations I have, okay? Y equals negative 2x plus 1, y equals 2/3 x plus 1, and write that in a piecewise function format. So it's going to look like this. Okay, f of x equals, doesn't matter which one goes on top, which one goes on the bottom. So I'm going to start with just my first equation for the top, negative 2x plus 1, and its domain again is x is less than or equal to 2. And then the bottom, I'm going to do 2/3 x plus 1, and then again, x is greater than 2 for that domain. Okay, so that's how you write the equation for a piecewise function. We have one more example now, just like that, number 5. And on this one, we have, again, 2 pieces. Okay, so this piece down here, I'm going to do this one in blue. It is a horizontal line, so that means this is a constant right here. Okay, it's on -5. Okay, so the equation for this one would just be y equals -5. Its domain is all x values less than, not including, okay, so no bar, +1. And then let's look at my red one. It looks like I have a point right here at 3, 1. It looks like I have another point right here. We'll call that 4, 4. And so its slope is up 3, right 1. Slope is +3. Well, if I continue that slope down, go down 3, left 1, there's a point. Go down 3, left 1, there's a point. Go down 3, left 1, there's another point. Okay, well, where would that put us? That would put us at, here's -5, -6, -7. That would be 0, -8. Again, if we were to continue that line and extend it down. Okay, we're not going to, but that would be the y-intercept if we followed that pattern. Okay, so the b value would be -8, and so that means its equation would be y equals 3x minus 8. And its domain is all x values greater than or equal to, because it's a solid boundary point, +3 is where we're starting there. Okay, so this piecewise function would be f of x equals -5 for a domain of x values less than 1, and then 3x minus 8 for a domain of x values greater than or equal to +3. Okay, if you had any questions over this, feel free to jot those down and ask those next time I see you. Until then, have a nice day. You're all wonderful people. Take care.